This is our tutorial for week 6 of our distance learning, and this week and next week and following week we're going to be reviewing solving equations. And we're going to start off the way we did way back at the beginning of the year when we were doing manipulatives and the sketch method. And since we don't have the manipulatives at home, we're going to be reviewing the sketching method first. And we're going to do that with the yellow ones, problem number 1 and number 2. We're not going to solve them. We're just going to review how to sketch them so that we can make sure our sketches are good, and then we're going to go on with the solving of them using the sketching. Now, as far as remembering how to do this, the thing that we need to remember that our variables, the thing that we don't know, the x, we're trying to solve for that, okay, that's going to be represented by a triangle. So on this very first example, I'm going to draw my line. This says 4 x's, so I have to draw 4 triangles. So, yuck. There's my first one, that kind of yucky. There's my second, third, and my fourth. And on the other side, it says I have 2 x's. I have 2 variables, which I'm going to represent as my triangles, so 2 x's. And then a number without a variable, the 10 is a constant. We represent that with a number cube. So a 10 cube. And that's a basic sketch. That's all we have to do just for the sketching, and we'll see how to solve that later. On number 2, I have on the left-hand side, I have 2 sets of variables, but I'm going to start off with the first one, 3 x's. I'm going to draw 3 triangles. But then after that, I have a constant, a 7. So I'm just going to draw that as a 7 cube. And then after that, I've got 2 x's again, so 2 more triangles. And then on the right-hand side, there's no number in front of the x, so we can put a 1 there. So that's 1x, so 1 triangle. And then the 11 cube, because that's an 11 constant. Now, if you remember, one thing that we can do after we just sort of get the basic drawing down is we can rearrange anything on one side. So if I notice on the left-hand side here, I've got these 3 triangles and then 2 triangles. I can actually group them together to show that I have 5 of them, and then do the 7 after that. So we can regroup to put things that are alike together. So instead of separating the 3 x's and the 2 x's, I can put them together and show that I actually have 5 x's or 5 triangles. And that's the basics behind how to do a sketch. Remember, the triangle represents the x, the cube represents a number without an x, just like a 7 or an 8 or a 9, just it doesn't have an x. Okay, now we're going to go on to some very simple equations. I'm only going to do 2 of them from your notes because they all work the same basic way. Okay, so I'm going to draw my line. Whoops. And I'm going to notice that it says I have 2 x's, so that's 2 triangles. And on the other side, I have a 6. That's a 6 cube. Now, as far as solving this goes, our very first attempts that we're going to show are what's called the guess and check method. So I have to try to figure out what number, because remember, the triangles represent a number that we don't know. That's why it's called an unknown or variable. What number I can put here, and it has to be the same number here, so that when I add them together, it equals 6. So if you just say, well, maybe it's 1, maybe a triangle, and I like to think of these like they're worth points. Maybe one triangle is 1 point. If I put a 1 and a 1 here, will that make a 6? So if I add them together, 1 and 1 is 2, and that does definitely not make a 6. So that's not going to work. So one triangle is definitely not going to be 6. So then, since that was kind of quite far away from the answer I wanted a 6. I ended up with only 2. I'm going to guess another number, but that's bigger. Instead of a 1, let's try a 2. So if each triangle is worth a 2, is 2 plus 2 going to make my 6 that I want? So if I do 2 plus 2, that's 4. And once again, nope, that does definitely not equal a 6. So one triangle isn't worth 2 points. So if I keep going with this, I can try 3. And notice they have to be both the same. I can't do one triangle be one number and the other triangle be a different number. They have to be the same number. So I'm going to look at, is 3 plus 3 6? So 3 plus 3 is 6. Okay, I got the same thing on both sides, and I did that when I made the pawn or the triangle or the variable x a 3. That means one of them, just one of these was a 3. And since I had two, I had a second one, but they both have to be the same. So since one triangle was a 3, I now know that x equals 3 because it balances on both sides. I get a 6 on the right side and a 6 on the left side. Now I'm going to look at number 6. This time it says I have 3 x's, so I need 3 triangles. And it says on the right side I just have a 27, so I'm just going to put 27 cubed. Once again, I need to try to guess or figure out what number I can put here 3 times that's going to add up to make a 27. Well, I already know that 2 3s is a 6, so if I think, well, I'm going to try 3s again and see if that makes a 27. When I add these, I know the first 2 3s, 3 plus 3 is 6, plus the next 3 is a 9, and oops, that very definitely does not equal 27, so that's not going to work. And it's way off, in fact. I got a 9 is much lower than a 27, so instead of just going up by 1 to a 4, I'm going to try hopping it up a little faster here. So I'm going to hop it up to, say, a 5. So let's try 5s. So I'm going to put a 5 here, where I have to have 3 of them. They all have to be the same, and see if that equals my 27. So when I add them up, so 5 plus 5 is 10, and 10 plus 5 is 15. Still not going to give me my 27. So that's still not correct. I'm still quite a ways off. So once again, I'm going to hop it up a little higher. And I'm going to try 7s. And see if that gives me a 27. So if I do 7s, so 7 plus 7 is 14. And 14 plus 7 is 21. Getting closer, but still not 27. And I have to have the same on both sides. I'm just going to keep hopping it up by 2 like I did before. So I'm going to try 9. I'm going to switch back to my blue. So 9, 9, and 9. See if that gives me my 27. So I have 9 plus 9 is 18, and 18 plus 9 is 27. So now I get my 27 on my right side and my 27 on my left side. That balances. I got that by substituting in for each triangle, or for one triangle, a 9. That means that my x is a 9 because one triangle represents one x. Now for the last little bit, we're going to see what happens if you don't want to just always do the guess and the check, because sometimes it gets kind of cumbersome always guessing and checking, but we can still use the sketch method if we follow some rules. So now I'm going to change to green. This one, notice we have what we call variables on both sides. I have x's on both sides. So I'm going to start off with number 1, and it says I have 3 x's. So I'm going to draw 3 triangles, but then it gives me a 7 constant. No x with it, so that's a 7 cube. And on the other side, I have 4 x's, so 4 triangles. Now, one of the rules with solving equations says you can do the same thing to both sides. So if I wanted to, I could actually add triangles to both sides. Like I could add one triangle onto this side, but then I would have to add one triangle to that side. And it's still balanced because I did the same on both sides. It doesn't really help me to solve it, but it's still balanced. But just like you can add triangles to both sides, you can also take off triangles from both sides if you take off the same amount. So that I'm actually going to do because I want to find out what one triangle equals. Not 3, not 4, but 1. So I can take off one on the left, but then I have to take off one on the right. But I still have triangles on both sides. I can take off another one on the left and another one on the right. And I still have triangles on both sides. So now I can take off a third triangle on the left and a third triangle on the right. And I no longer have triangles on both sides, but what I do have left is I have a 7 cube on the left side and a triangle all by itself on the right side. And well, now I'm done because I really want to know just what one triangle equals, because one triangle is an x, and this is telling me that x equals 7. If I want to go back and check this to see if I'm right, I'm going to erase this little triangle part. I can go back, and every place that there was a triangle, I can put a 7, because that's what we said a triangle was. Plus I had this 7 that was already there, that was a cube. And then I have my 7s over here. It doesn't always work out to be the same number every time, but in this case it is. So I have 7 plus 7 is 14, plus 7 is 21, plus 7 is 28 on this side. And on the other side, I have the same thing, which will be a 28. So same number on both sides, it balances. So that means that my answer was correct, x equals 7. Now on this last one, instead of having variables on both sides, I have my constants on both sides, meaning I have a number without a letter on both sides. And that changes it up a little bit, but we still start off the same way. I'm still going to start my sketch. So I've got a 14 constant, so that's just a 14 number cube. And then on the other side, I have 3 x's, so that's 3 triangles, and a 2 constant, so that's just a 2 number cube. Now, I can't take away triangles from both sides because I don't have triangles on both sides, but what I do have on both sides are number cubes. So I can take off number cubes or constants from both sides, but you have to be very judicious about which ones you take off. Do I take off the 14 or do I take off the 2? And it's not always that you take off the smaller one. What you do is you go to the side that has the triangles, because the whole point is to figure out what one of these triangles is. So to get one by itself, if you can, like we did over here with problem number 1, we got one triangle left. Okay, so we always try to get the triangles by itself. In order to get these triangles by itself, I need to take off this 2 cube. So if I take away the 2 cube, now the only thing that's left on here are my triangles. So now I have my triangles isolated. There's nothing else with them, just triangles. But if I take off my 2 cube on the right, then I have to take off a 2 cube on the left. So I'm going to show taking away, subtracting a 2 cube on the left. And I know that 14 minus 2 is a 12. And I'm still going to write it like it's a cube. You don't have to, but I like to. Now I'm back to sort of the guess and the check thing. I need to know what number, it has to be the same number, I can put here, here, and here 3 times. That's going to equal a 12. So if I think, well, let's just try 3. So if I put a 3 here, a 3 here, and a 3 here, and I add them all up and say, is that going to equal 12? So 3 plus 3 is 6, and 6 plus 3 is 9, and oh, I got close, but that does not equal 12. So that's not going to work, but I am close. So I'm just going to go up by 1 on this next one. I'm going to say that each one of these triangles is worth 4. I'm going to see if that is going to equal 12. So I have 4 plus 4 is 8, and 8 plus 4 is 12. So yes, I got 12 on the right, 12 on the left. That balances, and I got that by making one triangle equal to 4. And you can write it either that way, or some people, if you want to write it the reverse way, it's the same thing. You're just saying one triangle equals 4, and that means that x is actually equal to 4. And if you want to go back and check that to see if that works, I'm going to erase this part to show you how we do our checks. I'm going to go back to how I had the drawing originally. So I'm going to put that 2 cube back. So this is my original drawing. I had a 14 on this side, and every place that there's a triangle, these 3 spots, I'm going to put what the triangle represents, or the x, it represents the 4. So I'm going to put a 4 here, a 4 here, a 4 here, and I also still have this 2 cube. And you're going to try to add these all up and see what they are. So 4 plus 4 is 8, 8 plus 4 is 12, and 12 plus 2 is 14. So I do get 14 on this side, and I have 14 on that side. So it did work. It balanced it once again. So x equals 4 is the one number that makes this equation the same on both sides.